Here we'll be solving a multiple angle equation. Our multiple angle is 3x. So we're fine to solve this equation. Tan of 3x is equal to 1. Our trig function is already by itself, so we can now go ahead and find the arctan of 1. So here we have 3x. Well, the arctan of 1 from our unit circle, we know from our unit circle that the angle that gives us a tan of 1 is where sine and cosine are equal. And where sine and cosine are equal is where we have square root of 2 over 2 and square root of 2 over 2, which would be pi over 4. Also, down here in our third quadrant, we have negative square root of 2 over 2 and negative square root of 2 over 2, which is 5 pi over 4. So here we have two angles that will give us an arctan of 1. So from this we have 3x is equal to pi over 4 and 5 pi over 4. Now because they did not give us our interval, we need to write this in multiple angles or multiple solution or infinite solutions. So here this is one solution. If you recall from our last example, we said for tan function, because our period is n, it would be theta plus n pi. Now because it's theta plus n pi and it takes us to this angle, we could just do n pi. So 3x is equal to pi over 4 plus n pi. And this will give us our first solution when n is equal to 1. So this becomes 1n, which gives us 4 pi over 4, which gives us 5 pi over 4. And if we add it, when n is equal to 2, then this becomes 2 pi. And it takes us back to here, and so on and so forth. So here we have 3x. We're still trying to solve for x. So to solve for x, we need to divide everything by 3. So if we divide this by 3, divide this by 3, and divide this by 3, this gives us x is equal to pi over 12, since we multiply by the reciprocal of 3, plus pi n over 3. And here's our solution. In this example, we're asked to find the x-intercept of the graph. So here's our x-axis. It's our y-axis. From our graph, we can see that our graph intersects the x-axis at -1 and at +3, and multiple times before and after these points. Because this is our sine graph, we will have infinite possibilities of our intercepts. But let's look at this algebraically. To find x-intercept, we know from algebra that for our x-intercept, or y value will be equal to 0. So if we replace this with 0, this becomes 0 is equal to sine of pi x over 2 plus 1. As in our previous example, we're going to isolate a trigonometric function. So we want to try to get sine pi x over 2 by itself. So by subtracting 1 from each side, we get sine pi x over 2 is equal to -1. Now this is a multiple angle formula, so we can find sine pi x over 2 is equal to, or pi x over 2 is equal to the sine inverse of 1. We know from our unit circle that the sine inverse of 1 is an angle whose sine value is -1, and this would actually be 3 pi over 2. So we have pi x over 2 is equal to 3 pi over 2. Now, because our domain is not given, and we know this is a sine function, we know this goes up to 2 pi n for infinite possibilities. We're still trying to solve for x. So if we multiply both sides by 2 over pi, we multiply this by 2 over pi, and this by 2 over pi. Our 2's cancel, so we have x is equal to 2 cancels, 3 cancels, so we are left with 3 plus pi's cancel, 4n. So here's our general solution for the x-intercepts, where n once again is an integer. So if n is equal to 0, this becomes 4 times 0, so which is 0, and 0 plus 3 is 3. So here we get our value of 3. When n is equal to -1, this is 4 times -1, so because of -4, and -4 plus 3 would be -1. So here we have our second intercept. And by choosing any integer value for n, we can get our infinite possibilities for our x-intercept. Here's another example of a trigonometric equation which we're going to solve. We're given 3 tan squared x plus 4 tan x minus 4 is equal to 0. And we're asked to solve this using the quadratic formula. And our solutions is on the interval of 0 to 2 pi. Now if this could have been factored, we could have factored this and solved it by factorization. As you may recall, there are many ways of solving a quadratic equation. And this is even though it's a trig equation, it's quadratic in form, because here this is like our x squared term, and this is our x term, and this is our constant. So because this is our quadratic in form, our 3 is like our a, this is our b, and this is our c. So here we have our a, b, c, which we can use in our quadratic formula. And if you do not recall your quadratic formula, we know that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2 times a. So here our x is equivalent of tan x, so tan x is equal to minus b, so it's minus 4 plus or minus b squared, so it's 4 squared, minus 4 times a, which is 3, times our c, which is negative 4, all over 2 times a. Now this simplifies to give us 16 plus 48, which is 64, and the square root of 64 is 8. So here we have negative 4 plus or minus 8 over 6. If we do negative 4 plus 8, we get 4 over 6, which reduces to 2/3. And if we do negative 4 minus 8, we get negative 12 over 6, which simplifies to negative 2. So here we have tan x is equal to 2/3 or negative 2. To find x, we take the arctan of both of these. So we're finding the arctan of 2/3 and the arctan of negative 2. From our calculator, we have the arctan of 2/3 would be 0.5880 or 3.7296. The arctan of negative 2 would be 2.0344 or 5.1760. Because we're finding this on a solution of 0 to 2 pi, and 2 pi is 6.28. So within 0 and 6.28, we have 4 solutions for this equation. Here we have another equation, quadratic in form. However, this time, this one can be factored. So we're going to use factorization techniques to solve this equation. We're also told to use inverse functions where needed to find all solutions. And our solutions are in the interval of 0 to 2 pi. If we factor this, we have tan x minus 2 times tan x plus 1 is equal to 0. So tan x times tan x will give us tan x squared minus 2 times 1 would be negative 2. And when you add both of these together, you get a negative 1. So this is our correct factorization of this. Going back to our algebra techniques, we know from our zero factor property, we can set each one of these factors equal to 0 and solve. So we know that tan x minus 2 is equal to 0, or the tan of x is equal to 2. Similarly, we can say the tan of x plus 1 is equal to 0, or the tan of x is equal to negative 1. We know for our unit circle that where tan x is equal to negative 1, here we have the arctan or tan inverse of negative 1 would be 3 pi over 4. So if we go back to our unit circle, we have 3 pi over 4. This is where tan is equal to negative 1, and also 7 pi over 4. So our x solution here would be 3 pi over 4 and 7 pi over 4. Here we're going to find x also, so this becomes x is equal to the arc tan of 2. Since we're told to use inverse function to solve this, we can simply leave this as x is equal to the arctan of 2. And arctan of 2 is really a little over pi over 4. It's somewhere here. So this would be the arctan of 2. That means it's also as a reflection down here by adding pi to it. So x is also equal to the arc tan of 2 plus pi. So one solution, two solution. So this equation has 4 solutions. 3 pi over 4, 7 pi over 4, the arctan of 2, and the arctan of 2 plus pi. Here's another example of an equation quadratic in form, and we're asked to solve this again. Our interval is 0 to 2 pi, and we are told to use our inverse functions where needed. We can once again use our quadratic formula, or we can go back to factorization. Here this seems like it might be a little easier to use our factorization technique since both terms have secant x in it. So if we factor secant x, we're left with secant x will leave us with secant of x minus 4. Once again, using our zero factor property, we have secant of x is equal to 0, or the secant of x minus 4 is equal to 0. We know secant is the inverse of cosine, so then cosine of x would be the inverse of 0. The inverse of 0 is 1 over 0, which makes this undefined. This has no solution because we know that for cosine of x it will never be undefined. Here we can solve this by adding 4 plus 4. So here we have secant of x is equal to a positive 4. Once again, we can find the inverse of this. The inverse of secant is cosine. So we have the cosine of x is equal to the inverse of 4 over 1, which gives us 1 over 4. So here x is equal to the arc cosine of 1/4, which would be one of our solution, because we're trying to find an interval of 0 to 2 pi. And we know this is a positive 1/4, and cosine is positive in 2 quadrant. Our cosine of 1/4 is somewhere in the first quadrant, so 1.3. So here would be our x. We also know that this angle would be reflected down here in our fourth quadrant, since cosine is positive in our fourth quadrant. So to get this angle, we could take 2 pi and minus x, since there is equal to here. So our second answer for this would be x is equal to our cosine of 1/4, or 2 pi minus the arc cosine